Now let's look at this question in electrostatics. And actually this is WAEC, and it said the plates of a parallel plate capacitor are 5 millimeter apart. Okay, that's the distance, 5 millimeter apart, and we need to convert this to meter. So that'll be 5 times milli here implies 10 to the power minus. Alright, so and the area A is giving us 2 meters squared. Now the plates are in vacuum. Now the potential difference, that is V, is giving us 1000 volts. It's applied across the capacitor. Calculate the capacitance, charge on each plate, electric intensity in the space between them, and for the energy stored in the capacitor. And we're given permittivity of free space as 8.85 times 10 raised to the power of minus 12. Okay, now to this end, let us start with the capacitance. Now the formula for the capacitance is giving us C equals to epsilon naught A all over what? The distance. Alright, here we get to have that C equals epsilon naught, that is 8.85 times 10 to the power minus 12 times the area 2, then all over the distance, that is 5 times 10 to the power of minus what? 3. Okay, so let me do this. So punching our calculator, let's multiply 8.25 times 2, 8.85 times 2, and that will give us 17.7 times 10 to the power minus what? 12. Then all over 5 times 10 to the power minus what? 3. Now let's do it like this. Now this 17.7 divided by 5, now you get to have 3.54. Now times, now 10 to the power minus 12. Now taking 10 to the power of 3 over to the numerator, and according to the law of indices, this will become plus 3. Okay, so here you have that C equals 3.54 times 10 raised to the power of minus 12. Minus 12 plus 3 will give us what? Minus what? 9 columns. Okay, so now that is that. Sorry, okay, I'm always mistaking this. It should be farad. Okay, now the charge on each plate. Now the charge on each plate here, now the charge is giving us CV. Okay, and our C is giving us this, our V is 1000. So here we have that Q equals 3.54 times 10 to the power of minus 9 times 1000. Okay, now and our 1000 here, putting it in index form, is simple as saying 10 to the power of what? 3. Okay, so here we have that the charge will now be 3.54 times 10 to the power minus 9 plus 3, which will give us 3.54 times 10 to the power minus 6 columns. That's for the charge. Okay, now let's go for the intensity, electrical intensity, and that should give us that E V all over what? D. Okay, very simple. Our volt is 1000, then all over D, which is 5 times 3 to the power minus 3. So this should give us 1 times 10 to the power 3, which is for the numerator, then all over 5 times 10 to the power of minus 3. Okay, so this should give us E. So 1 divided by 5, that should be 0.2. Then times 10 to the power of 3 minus 3. Okay, but that will be plus. So Here you have 0.2 times 10 raised to the power of what? 6. Alright. So E now give us move this decimal here, minus 1. We have 2.0 times 10 raised to the power of what? 5 volts per meter. Alright, so we have to take the last one, and which is the energy stored. And the energy stored, W here equals 1/2 CV squared. Okay, and our C is so that'll be 1/2. Okay, let's see, 1/2. Then our C is actually 3.54 times 10 raised to the power of 9, right? Or minus 9. Then times 10 raised to the power of 3, all raised to the power of what? 2. So here we have 3.54 times 10 raised to the power of 9. Then times 10 raised to the power of what? We'll multiply this, we have 6. Then all over 2. So here we have 2 here 1, 2 here 1. Then remainder 1 in 15 you have 7. Remainder 1 in 14 you have 7. So here you have 1.77 times 10 to the power of 9 plus 6 is actually 15. So is the final answer, Joule. Okay, so you have that. Minus, so this should be 3, please. Minus 3 Joule. Sorry for that mistake. Alright, please don't fail to share with others. Thank you and God bless you.